Hi, this is S. Lakshmanachari, working as Assistant Professor in Department of Cyber Security, Institute of Aeronautical Engineering, Hyderabad. In this lecture, we are going to discuss the topic input or output interface. So, the digital computer system, mainly it has three functional parts that are central processing unit, input or output devices, and memory subsystem. So these are the three essential components of a digital computer system. So see here. So the input or output organization of computer, it depends upon the size of the computer and the peripherals connected to it. So the input or output devices organization, mainly it depends upon the two factors. One is it depends upon the size of the computer, and the second factor is the peripherals that are connected to the computer. So this IO organization mainly depends upon these two factors. So in this lecture, mainly we are discussing about the IO interfacing. So we are connecting several input or output devices with the computer. Okay. So these IO devices, we cannot connect directly with the central processing unit because there are some differences that exists between the central processing unit and the IO devices. So in order to overcome those differences in between the central processing unit and the IO devices, we are using a circuit that is called interfacing circuit. So the input or output subsystem of a computer, so referred as IO subsystem. So if you look into this basic computer organization, so this is a basic computer organization. So mainly it consists of three functional parts. One is the CPU, central processing unit, and second one is the IO subsystem. So IO subsystem, it includes input devices and output devices, and the third one is the memory subsystem. So these are the three essential parts of the computer. So we in this lecture we are discussing about the IO subsystem. So IO devices, IO input or output devices. Okay. So the input or output subsystem of the computer, in general, it is referred as the IO subsystem. And this IO subsystem, it provides an efficient mode of communication between the central system and the outside environment. So using the computer or central CPU, it can communicate with the user through some IO devices, input or output devices. So that's why this IO subsystem, it provides an efficient mode of communication between the CPU and the outside environment. Because the CPU, it is taking the input values from the outside world using the input devices. So after taking the input values, then the CPU will process that input data and it generates results. So that generated results are given to the user using the output devices. Okay. And so input or output devices attached to the computer are called peripherals. So the IO devices we can also call peripherals. So that means the input devices and output devices that are connected to the computer, so that are called peripheral devices. So we can call peripherals. Okay, so these peripherals, based on the functionality, we have classified into three types. So first one is input peripherals, second one output peripherals, and the third one is input output peripherals. So these are the three main classification of the peripherals. So first one is input peripheral. So input peripherals. So these input peripherals allows the input to the system. So that means these these input peripherals which allows the input data to the computer or system. Okay. So that is a input peripherals. Okay. So the examples of the input peripherals are keyboard. So already we know keyboard. So using the keyboard we can give some input values input to the computer. And optical input devices. So optical input devices. So under optical input devices, we have different types: card reader, barcode reader, digitizer, optical mark reader, screen input device, light pen, and mouse. So card reader. So card reader, it is used to decode the information from the microchip. Okay, so that is a card reader and barcode reader. So barcode reader. So suppose if you go to any shopping mall or supermarket, then some on some products there will be a barcode. So using this barcode reader, we can scan the barcode which is available on the product, so that it will captures the entire the product information. Okay, so that is a barcode reader and a digitizer. So digitizer is a device using that we can write, we can draw, and also we can do some painting on that. So that is a digitizer. And optical marker reader, screen input devices, and a light pen, mouse. So these are the input. And the last two is a trackball, joystick, microphones, and webcams. So these are the different input peripheral devices. And coming to the second type of classification, that is output peripherals. So output peripherals allows the information to the output. That means once the CPU generate results, that will be given to the user using this output peripherals. So we have different output peripherals like CRT. CRT means cathode ray tube. So CRT is a oldest type of display. So you're using some inside a picture tube, then the picture will be displayed on the screen. So that is a cathode ray tube. So but nowadays we are using some LCD displays, LED displays. So this is a CRT is it is the oldest type of the display. And the next printer. So we have different types of printers: impact, impact, inkjet, laser, dot matrix plotter. So these are the different printers. So printer is output. Suppose if you give any printer in the system, then it will gives the printer output. And speakers. So speakers are the output peripherals. That means it gives the audio as the output. And monitor. So it is a display unit. So it will display some pictures or videos, something. And coming to the third type of the peripherals, that are input-output peripherals. So till now we have seen the input devices and the output, input peripherals and output peripherals. So this third type of peripherals, that are called input-output peripheral. So the input-output peripheral means these type of peripherals which acts as both the input peripherals as well as the output peripherals. That is the input-output peripherals. So first one is a touch screen. So touch screen it is acting as a input-output peripherals, because when you touch the screen, it will acts as a input device, and after touching, it will display something that will be considered as a output. So that's why this touch screen it acts as both the input peripheral as well as output peripheral. And USB drive. So USB drive, using that we can copy the data from the one device, and we can send the same data to the another device. So that's why. So this USB drive, it acts as both the input device as well as a output device. Similarly, modems. So modem, it performs both modulation and demodulation operation. And last one, headset. So headset, it consists of the microphone as well as a speaker. So the microphone, it acts as the input device, and the speakers acts as the output device. So that's why the headset, it can be considered as input output peripherals. So these are the different types of the input output and input output peripherals. And input and output devices that communicate with the people and the computer are usually involved in transfer of alphanumeric information to and from the device, and the computer is ASCII. So ASCII means American Standard Code for Information Interchange. So that is a ASCII code. So in general, we are communicating with the computer. So that means the information will be exchanged between the user and the computer is in the form of ASCII code. So ASCII means American Standard Code for Information Interchange. So it is a 7-bit code. So it contains 7 bits of information. So the ASCII is a 7-bit code, but most computers manipulate an 8-bit quantity as a single unit called byte. But most of the computers, the 8-bit quantity it will be considered as a 1 byte of information. So therefore, ASCII characters most often are stored 1 per byte. And coming to the input-output interface. So already we have seen we are connecting different input or output peripherals with the CPU or computer. So we cannot connect these peripheral devices directly with the CPU because there are some differences exists between this CPU and the IO devices. So that's why in between them we are using one interfacing circuit. So that is called interface circuit. Okay. So here you can see how we can connect a CPU, memory, and input-output devices that are connected. Okay. So this is our representation how we can connect it. Okay. So the input-output interface provides a method for transferring information between internal storage. So internal storage is nothing but such as the memory and the CPU registers and the external devices. So peripherals connected to the computer need some special communication links or interface unit for interfacing them with the central processing unit. So these IO devices they need some special communication links or interfacing circuit when we are connecting with the central processing unit. So that's why we need a interface unit. So we have some differences between the CPU and the IO devices. So let's see the differences. So the purpose of the communication link or interfacing unit is to resolve the differences that exists between the CPU, the central system CPU, and the IO devices. So the first difference is the nature of operation. So if you consider the IO, if you consider the peripheral device, the nature of peripheral device is electromagnetic and electromechanical in nature because the peripheral devices it consists of some electromechanical devices as well as it is having some electromagnetic. So these are the nature of the peripheral devices. Whereas if you consider CPU, it is purely in electronic in nature because the CPU it is made up of all the electronic components. So that's why there are some differences there between the peripheral devices and the CPU. Okay, so that's why in between them we have a interfacing circuit. So that is a first one. So that is a nature of operation. And the second one. So second one is a data transfer rate. So data transfer rate. So the data transfer rate of peripherals is usually slower when you compare with the data transfer rate of the CPU because the CPU can execute the instructions at a million instructions per second. So that means a million instructions per second means it is a very faster, very high speed. But whereas the peripheral devices, they are very slower. So that's why there is a difference in data transfer rates. So that's why in order to synchronize their speed between the CPU and the peripheral devices, we need to use the interfacing circuit in between the CPU and the IO devices. So that is a second difference. And coming to the third difference is a data format. So data codes and data formats. So if you consider the peripheral devices, so the data format of the peripheral devices is it is in bytes. So when the IO devices is transmitting or receiving the information, generally it will be in the bytes. So bytes means 1 byte means a group of 8 bits, that is called 1 byte. So in bytes the data transfer will be takes place. And the CPU. So in CPU, the word format for the CPU is in word format. That means suppose if your computer is having a 64-bit processor, then that means the word size is 64. And similarly, if the computer is having 32-bit processor, then the word size is 32. So that is a word format. So the word format for the peripherals is bytes. So bytes, but for the CPU it will be in the words. So that is the difference. So in order to match these formats, then in between the CPU and the peripheral devices, we are using an interface circuit. So that interfacing circuit will convert one form to the another form. And coming to the last difference, that is operating modes. So the operating modes of the peripherals are different from each other, and each must be controlled as not to disturb the operation of the other peripherals connected to the CPU. So for the system, we are connecting several IO devices. So the operating modes of the peripherals are different from each other. Okay, so that's why when we are connecting more than one IO devices with the computer, the operation of the one IO device should not disturb the operation of the other IO device. So that is the operating modes of the peripheral. So mainly, so we have seen four differences that exists between the CPU and the IO devices. So first one is a nature of operation, and the second one is a data transfer rate, and the third one is a data codes and formats, and the fourth one is a operating modes. So these are the four differences. So in order to overcome all these differences that exists between CPU and IO device, we are using a IO interfacing circuit. So these components are called interfacing units because they interface between processor bus and peripheral devices. So this is a IO interface. So here you can see the IO interface. Okay. So see, this is a CPU, central processing unit, and this is a memory. So the CPU, it can access all the different IO devices. So how it can access it? So every IO device, it is having some address. It is having some hexadecimal address. Suppose if this is a IO device first one, this is IO device 2, this is IO device 3. Okay, so these are the different IO devices connected. So suppose if the CPU wants to access the first IO device, then the CPU will generate the address of that particular IO device. So that address, it will be placed in the IO bus of IO address bus. So the address bus, which will carries the address information from the CPU to the corresponding IO device. So suppose if the address of the monitor is 7A. So the CPU will place this 7A address in the address bus. So this address bus, it is connecting through this address bus to the interface circuit. So whenever the CPU generated address is matched with the address of the IO device, then the interfacing circuit will make a path from the CPU to the monitor in order to transfer the information. Okay. Suppose if the address of the address generated by the CPU is not matched with the address of the IO device, then that particular IO device will be kept in ideal. That means it will be in deactivated mode. Okay, it will not be active. Only when the addresses are matched, then only the IO device will be coming to the operation. And similarly, the data. So when the addresses are matched, then it will make a path. So IO interfacing circuit will make a path between the CPU and IO devices. Okay, so that means suppose whatever the data wants to be transferred, that is happening through the data bus. Suppose if the CPU wants to transfer some information to the IO device, so that data, it will be placed in the data bus. So this is a data. So this is a data bus. So that data will be placed in the data bus, and that will be connected to the data bus of the IO. So this IO interfacing also, it is having three buses. One is the control bus, data bus, and address bus. So all these three buses are connected to the corresponding buses which are connected to the CPU. Okay. So now we have discussed about the address bus and data bus. And third one is the control bus. So control bus, it is used to control the direction of operation. So so we are performing two types of operations with the IO devices, that are IO read and IO write. So IO read means reading the information from the IO device and we are giving to the CPU. So this is a IO read. And the second one is a IO write. So IO write is the data from the CPU we are giving to the sending to the IO device. So that is a IO write. So that means we are writing to the output device. Okay. So these two operations are controlled by this control signals using this control bus. Okay. So this is the interfacing circuit. So this interfacing circuit, it is having some internal registers. It is having some buffer register, and another one is the status register. So internally, this interfacing circuit, it is having this two types of the registers. So buffer register. It is used to store some information, because already we have seen the information from the IO devices, it will be takes place in the form of bytes. Okay, so that information will be stored in the buffer register. And the status register. So status register, it is used to know the status of the IO device, whether it is performing IO read operation or IO write operation. Okay, so this is about the IO interfacing, IO input or output interface. So each peripheral device has associated with it an interface circuit. So we are connecting several IO devices. Suppose if you connect three IO devices, then we require three interface input output interface circuits. Okay, so one is associated with one interface circuit is associated with each IO device. So suppose if you are connecting n devices, then we require n interfacing circuits. And each interface, it decodes the address and control received from IO bus. It interprets them for peripheral and provides signals for peripheral controller. So already we have seen this. So the interface circuit, it decodes the address and control bus, because so see here. So when the interfacing circuit will make a path between the CPU and the IO device, when the address generated by the CPU is matched with the address of the IO device. So for that purpose, the interfacing circuit will decode the address. After decoding, if the decoded address is matched with the address of the IO device, then that particular IO devices will be active. And the control information. So why the control information is required? Because we are performing two types of operation with the IO device. One is the IO read operation and another one is a IO write operation. So for that purpose, we are using a control signals because we need to know what type of operation we are performing, whether IO read or IO write. So for that purpose, we are decoding the control signals. It also synchronizes the data flow and supervises transfer between peripheral and processor. To communicate with a particular device, the processor places a device address on address lines. Each interface attached to the IO bus contained an address decoder that monitors the address lines. When the interface detects its own address, it activates the path between the bus lines and the device that it controls. All peripherals, those whose address doesn't correspond to the address in the bus, are disabled their interface. And coming to the functions of IO interfacing. So just before we have seen what is IO interface and what is the necessity of the IO interface. Now we are coming to the functions of the IO interface. So what the IO interface will do. So first one is it is used to synchronize the operating speed of CPU with respect to the IO device. So already we have seen the differences between the CPU and the IO device. In that, one of the factors is the operating speed, data transfer rate. So the data transfer rate of the CPU is very high, whereas for input or output devices, it is somewhat slower. So that's why, in order to synchronize their operating speeds between the CPU and IO device, we are using a IO interfacing circuit. And second one, it selects the input-output device which is appropriate for the interpretation of the IO devices. So it selects the IO device which is appropriate for the interpretation of the input-output device. So this IO interface, it is having some address decoding logic. So it will, this address decoding logic will match compare the address generated by the CPU with the address of the IO device. If both are matched, then that particular IO devices will be active. Otherwise, it will be inactive. And the third one, it is capable of providing signals like timing and control. So it is capable of providing signals like timing and control signals. And fourth one, in this, data buffering can be possible through the data bus. So through the data bus, we are sending the data from the CPU to the IO device or IO device to the CPU. And there are various error detectors are there. And it converts serial data into the parallel and parallel data to the serial. So suppose if you see this diagram, so this interfacing will convert the serial data. So in general, the data coming from the IO device is it is in serial. So it is in serial, but the data coming from the CPU is parallel. So this interface circuit will convert parallel to serial and serial to parallel. Okay, and the last point is it also converts the digital data into the analog signal and analog signal into the digital data. Okay, so in this lecture we have seen about what is IO interface and necessity of the IO interface and its functions. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.